Lecture 6. Chemical Reactions. An Introduction. Objectives. Learn the signals that show a chemical reaction has occurred. Learn to identify the characteristics of a chemical reaction and the products given by a chemical equation. Learn how to write a balanced equation for a chemical reaction. Why study chemical reactions? Chemical reactions explain how matter changes. Every process, from rusting iron to metabolism, combustion, and industrial synthesis, depends on chemical reactions. Core idea: in a chemical reaction, atoms are rearranged, not destroyed. 1. Signals that a chemical reaction has occurred. A chemical reaction is identified by observable evidence, not by simply mixing substances. Common signs of chemical reactions. Color change example: iron rusting, gray reddish brown. Gas formation, bubbles not caused by boiling, example, vinegar plus baking soda. Formation of a precipitate, solid from two liquids, example, AgNO3 plus NaCl(HCl)s. Energy change. Heat released, exothermic. Heat absorbed, endothermic. Light or sound emission. Important: a temperature change due to heating is not evidence of a reaction unless new substances form. 2. Characteristics of a chemical reaction. All chemical reactions share fundamental characteristics. Reactants are transformed into products. Chemical bonds break and form. Mass is conserved. New substances with different properties appear. Example.
Okay, here you have that hydrogen plus oxygen produces or yield water. The reactants in this case, as you can see, are to the left and products are to the right. And this symbol represents yield. As you can see, you have subscripts that indicates the number of atoms. And you're not supposed to change it, never, 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 never. And these coefficients that indicates the number of molecules or moles of each substance. That are the ones that you're supposed to manage in order to balance a chemical equation. The number of atoms in one side must be the same number of the same for the same atom, for the same type of atom. You must have the same number of atoms in the reactants than in the products. Look at this. 2 times 2, you have 4 hydrogen. And in the products, you have 2 times 2 is also 4 hydrogen. Then we can say that hydrogen is balanced. In this case, you have 2 oxygen. And look at here, you have also 2 times 1, because here we don't write the number 1, but it's supposed that it's here. 2 times 1 is 2. Then we have also 2 oxygen in the products. And in this case, we say that the equation is balanced. How can we balance a chemical equation? Well, based on that matter cannot create it or destroy it, it only transform. So the number of atoms at the beginning of each type is the same one in the products. What changes? Oh, here we have hydrogen and oxygen, and here we have a new substance, water, that is made of these atoms. Okay, let's continue then with the following part. Understand chemical
Understanding chemical equations. A chemical equation is a symbolic representation of a reaction. Parts of a chemical equation. Reactants t to a product's coefficients, numbers in front, moles. Subscripts, part of chemical identity. State symbols. S, solid. L, liquid. G, gas. AQ, aqueous. Example.
2 mayúscula N, se abre paréntesis, S se cierra paréntesis.
Okay, sorry. 2 sodium plus solid plus plus a molecule of chlorine that is made of 2 atoms of chlorine in the gas state produces or yields sodium chloride. Then here you have the reactants and here you have the products, and the arrow means yields. Here you have another example. Glucose plus oxygen produces carbon dioxide plus water. This is a combustion reaction and is the one that we use in our body to produce ATP energy from glucose. This is what we call coefficient, this is a subscript, and this is the formula of the atom, of the compound, sorry. The compound, the formula of the compound cannot be changed. The subscripts cannot be changed, but the coefficients can be modified in such a way that the number of atoms in the reactants will be the same one as in the products, according with the law of conservation of mass. What is exactly this?
Law of conservation of mass. Mass is neither created nor destroyed in a chemical reaction. Total atoms of each element must be equal on both sides. This law is the reason equations must be balanced.
Look at this. As you can see, methane, the mass of methane is 16 grams. The mass of oxygen is 32 times 2 because I have 2 oxygen. Then it is 64, and 16 plus 64 is 80. And here the mass of carbon dioxide is 44 grams and the mass of 2 molecules of water is 36. So 36 plus 44 is 80. As you can see, the total mass at the beginning of the reaction is the same one in the products. This is the law of conservation of mass. And according with this is that we can balance a chemical equation.
Writing balanced chemical equations. Step-by-step method. Write the correct formulas for all reactants and products. Count atoms of each element on both sides. Add coefficients to balance atoms. Never change subscripts. Reduce coefficients to the lowest whole number ratio. Example, balancing a reaction.
Okay, this equation is unbalanced. Why do you know that? I'm going to show you the way you can follow. You make a line here, and then you say hydrogen, hydrogen, oxygen, oxygen. How many hydrogen? 2. How many hydrogen? 2. How many oxygen? 2. How many oxygen? Only 1. Oh, it's not balanced. In order to have here 2 oxygen, what do I have to do? Multiply by 2. And then I will have 2 oxygen. But how can I introduce this here? By putting here a number 2, a coefficient 2, and now you will have 2 oxygen. Oh, but the hydrogen is also affected by these 2, so you will have 4 hydrogen. And here you have only 2. Then you have to multiply also here by 2 in order to get 4 hydrogen. How can I represent this 2 in the formula? By putting a 2 in the front, a coefficient. Now, the number of atoms of hydrogen at the beginning and at the end is 4. And the number of atoms of oxygen at the beginning is 2, and also 2 in the products. So I can say that the equation is already balanced because matter cannot be created or destroyed. Remember that this is the reason why we must balance a chemical equation. Well, here you have the step by step what you were supposed to do. And now let's continue interpreting balanced equations.
Interpreting balanced equations. A balanced equation tells us which substances react, which substances form, the mole ratio between substances. Example:
2 mayúscula H subíndice 2 más mayúscula O subíndice 2 tiende a 2 mayúscula H subíndice 2. Mayúscula O.
means 2 moles of H2 react with 1 mole of O2, producing 2 moles of H2O. 7. Common student mistakes. F. Changing subscripts instead of coefficients. B. Forgetting diatomic elements H2, N2, O2, F2, Cl2, Br2, I2, C. Ignoring state symbols D. Assuming all mixtures react. 8. Big picture summary. Chemical reactions involve the rearrangement of atoms. Observable evidence signals that a reaction occurred. Chemical equations describe reactions symbolically. Balanced equations obey conservation of mass. Coefficients provide quantitative relationships. One sentence takeaway. A chemical reaction is a controlled rearrangement of atoms that must always obey the law of conservation of mass. Tricky questions, chemical reactions. 1. Evidence versus process trap. Which observation alone does not guarantee that a chemical reaction has occurred? A formation of a solid when 2 solutions are mixed. B. Release of heat. C. Change in color. D. Formation of a new gas. White heavy check mark. Correct answer. B.
Okay, then here, which observation alone does not guarantee that the chemical reaction has occurred? Formation of a solid when 2 solutions are mixed? Not necessary. Release of heat? No, not necessary. Change in color. Well, release of heat is the only alone does not guarantee that the chemical reaction has occurred. Then this is the correct answer. Why? Because heat can be transferred without a chemical reaction in a physical process. Like C, for example, a reaction versus a mixture. Which situation represents physical change, not a chemical reaction? Iron rusting, of course, it is a chemical reaction. Gas bubbles forming from vinegar and baking soda. This is a chemical reaction. Sugar dissolving in water. Because there is no change in the type of substance during this the process of dissolving a solid into a liquid. Then this is the answer. Combustion of gasoline. Oh yeah, it produces new substances. So this is a chemical reaction. Then physical change is when matter doesn't change. Only changes the form or maybe when the products are at the same and at the end, the same ones. There is no change in the type of compound. Let's see, conservation of mass trap. If a reaction occurs in a closed system, which statement is true? The number of molecules stay the same or stay constant? No, not necessary. The mass of products equals to the mass of the reactant. Yes, that's true. That's true. The law of conservation of mass. The volume always decreases. Not necessary. Energy is always released. Not necessary. It can also be absorbed. Then the correct answer is B. Mass is conserved even when molecules rearrange. Okay. In this formula, in this reaction, what do coefficients represent? The coefficients are this number in front of the compounds. So the 2 and these 2 are the coefficients. What do they represent? They represent the number of atoms? No. Relative masses? No. Relative moles? Yes. Electric charge? No. Then we can say that the coefficients describe the mole ratios, not atom counts. Subscripts in the coefficient trap versus coefficient trap, which change could correctly balance this equation? No, this no, this no, this, let's see, add a coefficient 2 in front of HCl, let's see, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. Yes, this is the answer. Adding subscript, never, never, you cannot do that. Let's continue. The diatomic element trap. Diatomic are the molecules that contains 2 atoms. For example, chlorine is always diatomic, oxygen is always diatomic, hydrogen is always diatomic, bromine is always diatomic. So, which equation is incorrectly written? Let's see. Sodium, chlorine, this is correct. This is correct. This. No, this is not correct. Because here you have 2 oxygen and here only 1. Then you have to put a 2 into here and a 2 in front of here. Then this is the incorrectly written. Let's go to the following question. Product identification. Products always resemble reactants. No, not necessary. Products are mixtures of reactants. No, not necessary. Products have new chemical properties. Yes, that's true. That is true. Products always form solids. No, not necessary. Then, logic, precipitate, logit. Let's see. Which observation best confirms a precipitation reaction? Well, temperature increases. No, I don't know. Light is emitted. I don't know. A solid forms. Yes. If a solid is formed, you are in front of a precipitation reaction. Let's go. Why must coefficients be whole numbers? Coefficients must be whole numbers. Why? Because atom cannot be split. That's the answer. In a chemical reaction, reactants are found on the right of the arrow? No, to the left of the arrow. That's the correct answer. Okay. So here you have more questions. And also you have here the correct answer. You can stop the video and you can get more practice from these questions. I hope that now you understand a little more about chemical reactions. But before I finish, I want to tell you that there are several types of chemical reactions. Which are them? Well, when you have, for example, A plus B that produces AB is a combination reaction. The opposite, if AB, this compound produces A plus B, is a decomposition reaction. If you have A, B plus C, and then you have that in the products you have A, C plus B. What is happening here is a simple displacement. It's a simple displacement or single displacement, also known. But if you have A, B plus C, D that produces A, D plus C, B. Sorry. CB, yeah, I am right. CB, in this case, is a double displacement. It's a double displacement because one atom here, A, takes the position here of C, and C goes and takes the position of A. This is a double displacement. And all the reactions, for example, CH4 plus O2 and this reaction produces CO2 plus water. In this case, we are in front of a combustion reaction. Combustion reaction. Also, when you have an acid plus a base and you get a salt plus water, you are in front of a neutralization reaction. Whenever you have an acid and a base and you get water and a salt, you are in front of a neutralization with you here, sorry. Neutralization reaction, and here a combustion reaction. Well, these are the different types of reaction, the classification of the chemical reaction. With this, we finished. Remember what is important, the evidences that you are in front of a chemical reaction, that is a chemical change, that undergoes a chemical change, how to balance the chemical equation based on the law of conservation of mass, and also the different types of chemical reaction. Thank you, and see you in the next lecture. Remember, you can send me a message and ask me anything that you don't understand, and even though you can also send me a message and tell me, Professor, I need to meet you by via WebEx, and then you will tell me the day and the best hour for you. If I can, we are going to meet. If not, we are going to get a deal in order to meet. Thank you.